Our speaker tonight was the first non-founding employee of the world's second largest sports site, Bleacher Report. Please welcome the Senior Director of Engineering of Bleacher Report, Tung Nguyen.
So I'm not going to actually stand in front of the projector here, or TV. Can you guys hear me? Yeah. Okay, great. So instead, I'll stand inside so you guys can actually see it. Put this a little bit down. Okay, quite a crowd. Thanks for coming out. And yes, I'm the Senior Director of Engineering at Bleacher Report. I'm going to talk about one of the services that we run that powers the sports site that I operate here. The service is called API. And specifically, I'm going to talk about scaling. You guys can all hear this stuff? And Redis and how we leverage Redis to kind of scale this, at least part of our app, our site. Before I kind of get started, I just want to survey the room. How many people here actually use Redis? Good, about 2/3. Okay. So yeah, a lot of lessons learned in using Redis. I'm going to talk a lot about those lessons, and hopefully, I wish somebody told me these lessons many years earlier. It's been quite an adventure. So a little bit more about the site, Bleacher Report. It's, as Eric mentioned, the second largest sports site in the world here. When I started in 2007, we were doing about 50 uniques a month, which is about the size of a football stadium. It's not bad. No, pretty good. But of a difference nowadays. About 80 million uniques a month now. It puts us up, competitive with ESPN. It goes ESPN, Bleacher Report, then Yahoo Sports. We're bigger than Yahoo now. And after that, CBS Sports and SI, and kind of down the line. Running this has been quite fun. So let's go back here. Growth over the years, and that's our Google Analytics graph in the bottom there. That line has just been constantly going up. It's just me trying to keep up with that line, basically, for a long time. A lot of challenges there. The team is about 30 engineers now, 31 to be exact. Of the engineering team, 3 are operation guys. But as of about a year and a half ago, there was only 1 ops guy in the entire engineering team, with a team of 31. You're looking at him, the only ops guy that ran this site. Those 3 ops guys are helping, but they're still kind of learning. A lot of kind of experiences kind of along the way. And I'm going to talk about those experiences now. The next one, Bleacher Report app. So that's a picture of the Winchester House in Campbell, California. It's near San Jose. I don't know if anybody's been there yet. It's the Winchester House is called the Winchester Mystery House in California. It's a tourist attraction kind of. It was made or lived in by the widow of Mr. Winchester. In the Civil War, there was he sold guns to both sides, both the North and the South, and he killed a lot of Americans. Both sides of the war he sold to. He made lots of money, and when he passed, he left behind his wife, and his wife became kind of insane. She was haunted, according to herself, by the ghosts of all the slain victims of her husband's guns. And these ghosts would tell her that, if you stop construction of your house, we will kill you. So she kept on building rooms to this house, and she didn't do any planning at all. She just hired a bunch of construction workers, don't stop building, so every single day, construction. So it has doors that, how do you get to that door? You can't. It doesn't make any sense. Unless you guys have done software design, this building makes perfect sense. This is the Bleacher Report app. 7 years of technical depth and legacy. Monolithic, it's a beast to deal with. Low code base, we're in Rails 2.4. Rails 4 just came out. Jesus Christ. It's hard to scale, it's hard to maintain, and it's very difficult to use new technologies on it. So how do you scale this site? Well, some problems are big enough to run away from. So you don't. You kind of break up your application into services, SOA architecture. So around 2009, November, it was our first kind of exercise of or our first really production service. It was a small, lightweight notch wrap. It controls some of the CMS tooling that the editorial team uses. And then after that first service, we built a couple more internal services within Bleacher Report. Today we have about 13 different services. They all scale kind of independently. They're written in several different languages. Some of them are Rails, some of them are Sinatra, some of them are Node.js, and some of them are Elixir. Kind of cool stuff. 2009 was our first service that actually leveraged Redis. That was our first experimentation with Redis. It was called Pop. So Pop is like pop, like articles are popping. So that little hit counter right there that says 34,000 reads, that little stupid box right there requires its own service to keep track of accurately and in real time. So we started several versions of this, of scaling that little box right there. The first version was incrementing a denormalized counter on the articles table. So this is pretty standard stuff. Rails is supports this out of the box. And that gets you by for a while. And then, but eventually just updating that counter, even in a denormalized fashion, it's going to overload your database. So we had a second version of this where we moved the hit counters. We aggregated the counts in a separate table that was off of the articles table. So once the resource intention wasn't there anymore, and we used, instead of NLDB, we used MySam. MySam has some good database characteristics that makes it kind of useful for that purpose. So, we rolled that out, and that lasted for a while. And then we have kind of asynchronous jobs in the background, aggregating that count data, and then, saving it back into that denormalized counter. So that lasted for a good, 9 months. And then, eventually, we kind of hit the limits of that. So then our third version was like, okay, you know what? Let's just do the right way. We took shortcuts, that's fine. We have to do it then. But now we're going to try Redis. And Redis has this very useful incrementer command. It's a guarantee to not lose the hit count. So we're like, okay, let's use it. Let's try it. So this POP service with Redis is still in service today. I think that was released in 2009. So that's 5 years and it's still running just fine. Just looking back, hindsight is 2020. We should just use Redis right from the start. That was a waste of time, the second version. But yeah, that was our first experimentation with Redis. Then the next scaling challenge, 2012, this is early 2012. We've had I think at this time 4 or 5 different services. We were looking at the Bleacher Report, that main service, or the main application there, and it was starting to get load again, and I remember the traffic just kind of going up. And I looked at New Relic throughput, and I could see that most of the throughput, 70% of the throughput were coming from API calls. It was serving back API JSON payloads. And we realized there's an opportunity for us to kind of scale that component by breaking down to a separate service. So that's kind of what we did. This is what the API response looked like. There's just a hash, items is the key, and there's an array of different types of content. We sometimes return tweets, return articles, return pictures, and but this list of content is just generally a list of content that's based on a category of different sports teams typically. Just looking at that payload and looking at what we need, and then looking at Redis, look at all these very useful operations Redis has. Set operations, sadd, smembers, mget, lrange, lpush, ltrim. All very useful to process lists and kind of sort sets. Ruby is a great language. It's one of the most beautiful languages, I think. But it's not as fast as in kind of processing data. You could do it in C if you want. And we did that for a while. A developer was like, oh, I'm going to do this in C. And it's like, he did it very fast. But, it's already built in Redis, and Redis is, I believe, implemented in C. So basically, you're kind of, it's there for you already. You're saving yourself a lot of work there. So that makes a lot of sense for us. We also started using Redis for our queue processing system. We've been through them all. BJ, DJ, Starling even, and now Rescue, and now Sidekick seems to be the coolest kid in the block now. But yes, we experimented with Rescue also. So 2013, we finally deployed the API app. That was good. By the kind of end of that March, we moved some traffic. You mitigate risks. You get larger. Like you can't just break the site. You piss off 80 million people. It's not that fun. But we mitigated some risk by moving some traffic over. And by the time May rolled around, we moved 75 to 70% of our traffic over to API. So that made it, I felt like, just in time. So that was great. We continued scaling and we continued growing. And additionally, we released our Team Stream app. Bleacher Report has a Team Stream app also. It's our version of our site as an iPhone app or Android app. They released that in 2011, but it started getting really popular, picking up steam around 2013. And so with the newest version of the Team Stream app, we're like, don't use the old API, use the new API. And like, we're not going to support the old API anymore because it's slower. So it just all kind of serendipitously kind of happened to work out at the same time there. Scaling challenges. So I wish there was like a book or like a school. If you guys know one, let me know. Where somebody could teach me how to scale versus just kind of learning through blood, sweat, and tears. But we ran into another issue. 2013 September, like everything was going great for a couple months there. And then we used, as I mentioned, a queuing system named Rescue. And Rescue has a plugin or gem that you can add on to the queuing system. It's called Loner. Loner, like you're by yourself. When you're, let's say, scheduling a bunch of queue jobs, let's say every 10 minutes, and those jobs take, let's say, unfortunately 15 minutes to run, then you're going to have kind of overlapping jobs. When you have overlapping jobs, your queue is going to have out of control eventually, and you're going to exhaust the rescue queue. The Loner guarantees a unique job. In order to guarantee a unique job, what Loner does is internally, we found this the hard way, it uses something called a keys command. And keys command increases the time complexity, which basically means it takes a lot longer as your data set grows. And there's a screenshot, I just grabbed this off of Redis.io, the open source documentation there. Warning, consider keys as a command that should only be used in production environments with extreme care. It may ruin performance when it gets executed against large data sets. Yeah, I mean, it's right there in the documentation, you know. And Memcache is interesting too because they're kind of like key value caching store. But Memcache authors have decided not to even build the keys command because they're like, we're not going to give you enough rope to hang yourselves, guys. So it's there. And I wish you guys know the author Loner. Maybe you could work on changing that implementation. But anyway, Loner is a great plugin. We still use it. But what we kind of realized at the time was there's a Rescue Redis server database need, and there's a Redis database need for the main data store, the caching layer. And we could segregate those. So that's what we did. We just moved this to another database, and that scaled. And that fixed the problem. So yay! Unfortunately, 2014, common theme here, right? We started hitting another limitation of Redis. So Redis is evented based, which basically means it's kind of single threaded, only can take advantage of one CPU core. And even though this machine here that we have running our Redis service at that time has 8 cores, it can't take advantage of all 8 cores. It just can't. So I wish there was a config there, just like, you know, you configure a number of threads to run, and then like, oh, magically take advantage of more cores. It doesn't work that way. So even though the load average says 1, and in theory your load average moves to 8 on an 8-core machine, we're pretty much pegged. That's why it says 100%. So what we did was, well, we ran away from the problem. We put CD in front of it. This front, and we did it in half a day because we were having production issues. Thankfully, API is easy to put CD in front of it because of the simple responses that they return. So the CD in front of API buffered a lot of traffic. That chart on the right hand side, that's an optimized CDN chart. It's showing the edge hits and the origin hits. That's a really outdated graph. The cache hit ratio is around 60 to 80%, depending on the type of traffic it's serving at the time. So that really helped, and then we're like, okay, yeah, let's go back to party. Nope. So what ended up happening was that helped us for a couple months. But then we kind of deployed new features, and the new features took advantage of more Redis calls. So this was, I think, the stores feature that we were running off of API, and it used a zset operation, and that zset operation, even with pretty much the CD in front, would still end up hitting that single CPU core bottleneck. So that's a New Relic chart on the right there, showing our response times. Is just, it's terrible looking. It's just all over the place. Average response times of about 430 milliseconds, but that's not good. So then at the time, I was kind of looking at, okay, what do we do now? And I went on Roku's kind of web page, and Roku has an add-on page, right? And if you click on the add-on page, you can see all the partners that Roku kind of partnered up with, and all the services that are out there that could help you. So I went there, and I saw like there were 5 different Redis cloud providers out there, cloud Redis providers. Like maybe they can manage this Redis server better, maybe they did something. And I remember kind of reading a blog article that finally led me to Redis Labs. And Redis Labs, or before I guess I'm jumping ahead there, but I knew I needed a clustering. I knew a single CPU core bottleneck wasn't getting me there. So I was looking at the open source documentation also, and you can see these are screenshots that I took, what, 2 days ago? This is 2 days ago. Where it says Redis cluster specification, work in progress. Redis cluster over there, currently not production ready, but usable. Then on the bottom right there, the Redis cluster tutorial. Redis cluster is currently alpha quality code. That's exactly what you want to hear. So yeah, that kind of sucks. So I know I needed Redis clustering, and that's when I looked at Roku and I found out, oh, Redis Labs is there. I remember this from about 2 years ago or something. It was just back in the back of my memory banks, and I remember that they were like the second contributor to the Redis open source project itself. This is a company, and they're the second contributor to this open source project. So what they basically do is, and through researching all that and through some phone calls, I learned that they run an accelerated version of Redis. It's a tuned version, and they already support clustering. So they're a little in front of this compared to the open source community. I'm a pretty big pro open source advocate, but I'll use the right tool for the right job. Clustering is also transparent via Redis Labs. They expose a single endpoint for the developers and the clients to handle, and you just connect to that. The clustering just like, you don't handle the clustering in the app layer. You handle the clustering behind the scenes at the database layer. So that's kind of cool, but talk is cheap. What does actions speak louder than words for me? So we got tested. You can't just throw in there and hope and pray. Though I've done that. So in testing Redis Labs, benchmarking is basically what you want to do. But benchmarking takes time, and a good engineer or a good benchmark engineer will tell you that these benchmark results are really good for this set of input data. They will always qualify. At least a responsible benchmark engineer would say that. Getting that input data right is an art as much as a skill. So it's just art as much as a science. So we didn't have time for that. So again, back in my memory banks, this is a technique I used many years ago. It's a gem called EM proxy. And EM proxy, what it basically allows you to do is intercept traffic from any server and duplicate it or duplex it elsewhere. So there's 19 lines of code. You could throw this on a production server running live code and then duplex it to another cluster that you can spin up. So in our environment, we could spin up a full cluster, and not just one layer, but 5 layers of the API stack in about 5 minutes. And then from there, it takes about 20 to 30 minutes to actually be warmed up and usable. And then from there, you can use this kind of trick to test with real live production data without affecting the user. So open source Redis is on the left there. You guys saw those spikes from earlier, about 430 milliseconds of response times. Redis Labs in a cluster I spun up in about 30 minutes. It's running Redis Labs. Look at the difference in those charts. One's very spiky. One's a smooth 55 milliseconds response time. And I usually don't believe in magic or silver bullets, but I have a silver bullet up there for a reason. very little work for us to kind of get us on a more scalable Redis solution. And remember, what the context of this is one ops engineer. So Redis Labs response times, as part of kind of Redis Labs offering, they also provide performance metrics through a New Relic plugin. It's good to have the vendor tell you we're fast, but it's great if they can prove it through kind of performance charts. So that's what they do through the New Relic dashboard. This is just showing the throughput, and on the right there is showing the latency graph. And I was looking at that, I hover above it, I was like, wait a minute, the y-axis, that says milliseconds, but it says point something. We're talking about nanoseconds here, the response times. That's insanely fast. I mean, who cares if it's twice as slow? It's still only, a millisecond versus half a millisecond. So Redis Labs is fast, or Redis is really fast already, honestly. Redis Labs is even faster. And there's a kicker here. I'm mentioning right now, basically, we did this without clustering. So I went into Redis Labs thinking we'll need clustering, right? Because the CPU core bottleneck. But when I first originally kind of put us on Redis Labs, clustering requires some app code modification. In order to make it work, you have to give hints to the clustering engine. And so what ended up happening was I requested them to put me on a single shard. And we did that, and I was still getting these performance benefits with a single shard. So that's pretty cool. And let's see. Great job. So at this point I went fishing, and that was cool. I had a beer. Nope. Back to it, guys. So new features went out, more personalization went out. They released another team stream app. It required more demanding Redis operations, and that killed us. Redis slow log is basically it's like the MySQL slow log. It's a command you run their CLI, and then it'll tell you what your Redis operations are. It's very similar to the MySQL slow queries. And DBAs kind of complain to app guys all the time. They're like, look, dude, MySQL can't scale. You just can't write slow queries, right? Or you have to index it or whatever. Redis is the same thing. We're doing some bad things. So we basically started having this chart again, even with the Redis Labs in front. But remember, I still have some. That's Tinkerbell. I have some magic pixie dust still. We can still do clustering. So that's what we did next. We changed our app, and clustering requires you to change your app to kind of, if there's a key that you're using in Redis, you have to put these curly bracket notations around it. So it gives the suggested hints to the Redis Labs clustering engine, so it knows which shard that data belongs to. It's actually in the open source spec. Redis Labs just implemented it. They work very closely with the open source community. So there's a chart before and after. There are spikes, and there's still some spikes on the right side there. But it was better, much better. You're looking at an average response time of 446 milliseconds versus 53 milliseconds. That's pretty cool. And then we optimized, we tuned, we fixed those queries, we scoped the queries so that we're not, loading all the records in the last year. We load all the records in the last week, and then we're just smarter about that too. So this is our response times today in API. As of a couple days ago, 38 milliseconds, so even better than 55 milliseconds that I saw earlier. So yeah, that's pretty fast. Redis is not the bottleneck there. It's just the app code and the response, it's the app itself. So just over the years, what we've kind of done successfully, and I've seen companies do this successfully, and I've seen companies fail doing this too. So it depends on the team and everything. But we break out our monolith app into smaller focused services. Then we kind of optimize that separate service. Then we leverage the right tools and partners in order to kind of scale the site there. A little bit more about Bleacher Report. We're pretty big pro open source guys on the team. Chris Pedrick, he's the director of front-end engineering. He has an open source project called the Web Developer Toolbar. It's a pretty good popular plugin for Firefox and Chrome. Winton is another kind of director of engineering. He's released Stasis. It's an open source framework to generate kind of static sites. It's the second largest and most popular Ruby static framework release, as far as I'm aware. Myco Doxy, it's a Go project I just wrote last week that automatically helps with development. Docker's moving very fast. It reloads your Nginx environment with a dynamic container port as you kind of restart your Docker containers. Jimmy is one of our ops engineers. He runs learningdocker.com. It's a site with tutorials around Docker. Very kind of exciting stuff around there. Felix, he's another ops engineer. He wrote a project that improves the way Elastic Beanstalk provisions servers and deploys code. And so it was this tweet on the AWS Elastic Beanstalk Twitter feed recently, and there's me, and I wrote a couple different open source projects too. And we're looking for people. If you guys are into that, come talk to me. And lastly, just Redis Labs. They're right here. Eric. There you are, Eric. Sorry, Cameron. Cameron's from Redis Labs. He's here. I see kind of vendors like AWS, Redis Labs, and a couple other vendors that I've worked closely with over the years as kind of extension of your team. Like, you're not going to be successful unless these partners are successful too. So it's about choosing the right partners, and kind of and hopefully they're successful, and then that helps us be more successful. So I think Redis Labs is coming out with an enterprise offering. If you tweet this, then you're gonna, and Cameron can talk to you guys more about this. Then there's more prizes to be won and everything. And I think he's the one giving out the drone. So thank him. Thank me.
Yeah, guys, we're giving out another drone to someone who tweets that. We're trying to get into the enterprise. If you can tweet this today in the next few hours, that would really be appreciated.
So I think
you can also get it on @Redis Labs Inc. on our Twitter.
So Eric, I think you want to close out, and then the Q&A session.
All right, before we move on to Q&A, I want to give a great big round of applause to Tung Nguyen. As mentioned before, good questions do get t-shirts. So start off, who's going to ask the first question? Your hand went up way quick.
Right, I think the most obvious question is, how expensive is Redis Labs?
They have different tiers of pricing depending on how large you are. When you're small, then it's not that big deal. When you're larger, then the pricing is basically negotiable. So Cameron, can I handle that?
Yes, right over there.
Did you consider using Varnish as a caching layer at your app stack?
We did, and I have friends who, so the question was, will you consider using Varnish as your cache layer? So repeating the question might help. We did. We looked into that about 4 years ago, and when I set it up, unfortunately Varnish didn't work out very well for me, and I realized a couple years later, because my friends who run HTracks.com do use Varnish, and they've used it very successfully. But you have to tweak the memory setting configuration extremely low, like a tenth of what the actual server actually has. It's ridiculous. And like, I didn't figure that out at the time, so there's some experience there probably that might help. But Varnish is definitely another way to do it. There's many ways to do this. Next question?
Wait, hang on. Just one thing I forgot to mention. We are giving away the drone. In order to win it, you do have to have your card in this bucket, so please pass this around, because a lot of people came in after we announced that. And yes?
What was our peak usage of your API? What time was the peak usage?
Oh, what time is the question is, what time is the peak usage of our API service?
Yeah.
During the day, so we're in an auto-scaling environment, and during the day, our servers will go up because we get more traffic. But peak time is typically Monday when people get to work and are not actually working and are checking sports. So Monday mornings, like, it just picks up, and then all the way till basically when they about go home from work. So those are kind of peak traffic hours.
Probably should fix that, check you architecturally wise how to separate it and put it into microservices so to have it like a chapter server.
Yes. So I think he was just commenting on how we separate our services to many, our application many services, and we can still each component independently.
All right, when someone gets 2 prizes, our regular here knows what to do with it. Go for it. That's it. Whoever grabs it, grabs it. Very good. That hand over there.
If you have Akamai in front of Redis, how do you ensure the freshness of the API response? It takes 7 minutes to clear one URL in Akamai. If you need a fresh response, what do you do?
So the question was, if we have Akamai or CDN in front of our API service, how do you ensure freshness to these responses? So you use a smaller TTL, is one answer. You can't rely on purging CDN caches, because purging a CDN cache, at least on Akamai, takes 10 to 15 minutes. That's not going to do it. I've heard there are some tricks to kind of get around this. But I also have heard there's other CDN providers out there. There's Limelight, there's Edgecast, there's Akamai, there's CloudFront. All of them, unfortunately, are still CDNs. Fastly is an interesting story to me. Fastly, I wouldn't even call them a CDN. So most CDNs encourage cache off their edges in 10 to 15 minutes. CloudFront, I think the expected time is 60 minutes. Fastly, you can do it in 150 milliseconds. It's a game changer. It's a little bit different. And Fastly is part of our varnish. The guy who asked the question about varnish.
Yes, right there. What's your backup procedure for Redis?
Backup procedure for Redis? On Redis Labs, maybe Cameron can answer that. But basically on Redis Labs, you can set up a multi-AZ configuration. And what they do is, because Redis is not like an Memcache, you can actually write to the disk. They write to the disk and then they replicate that disk to another AZ. So then they would fill up the AZ if one AZ goes down. That's what Redis Labs has done. When we were running our own version of Redis, we just replicated to another node and kind of did the same thing, but it was much more manual and automated.
You do a replication and manually copy?
Yes.
Okay. Thank you. Yes,
You're welcome.
Did you actually persist objects in the Redis database, or was it just a copy from like a MySQL?
So the question was, did we actually persist data into the Redis database, or was it just a copy from the MySQL database? I mean, we were persisting data into Redis. Okay.
With your API call back to Redis, do you also handle the tokens through Redis, or do you have that separated because it's an API call?
So the question was, with the API calls to Redis, do we also pass the API tokens to Redis?
Yeah.
So Redis, for us, we don't use a password token or anything like that to contact with it. We use firewalls and security groups, so it's only accessible from within the kind of the cluster, from within the server environment.
Here's got two. Throw it up. There you go. Someone's not paying attention. All right. Yes.
Where is Redis Labs located in relation to your app, and did switching to it add any network latency?
Sure. So where is Redis Labs located in relation to our app, and did it introduce any latency? So Redis Labs, I believe, has 3 cloud providers. Cameron might know the answer to this a little bit better than me. I think their main 3 cloud providers are AWS, IBM Software, and
Google and Windows Azure.
Google and Windows Azure. So they have 4. We are on AWS, so we chose AWS. And here's the thing that's kind of crazy with Redis Labs. Within AWS, the region breaks out to AZs. And on the West Virginia, there's 5 AZs, A, B, C, D, and E. With every customer that signs up for an account, my A is different from your A. And so everybody's customer has, they do this, they randomize it, so everybody's not on A. But the thing that sucks about that is Redis Labs is a third-party outside vendor. They're not in the same region or account as us. So their A might be different from everybody else's customers' A. So what Redis Labs has done is there's a kind of hidden endpoint that you get a query, then it returns kind of like a random identifier. It's not actually really random. The identifier actually identifies the actual AZ it belongs to. So you can provide your account details, like an INA key, and then Redis Labs will use that metadata information to map the right AZ to any AZ. So you can get your Redis server on the same AZ within the same region. And then when you're talking within an AZ, I believe the expected response times are between 1 and 10 milliseconds. When you're talking across AZs within a region, I think you're talking about 20, 30, 40 milliseconds, typically. Not really that big of a deal.
In that corner.
At the current trajectory you're at of growth, if and when would you pass ESPN for a high attractive sports side, right? And if not, features in your apps or site would you highlight to reach that plethora?
So the question coming from the gentleman in the corner there was, when is Bleacher Report going to pass ESPN? The answer is soon, and hopefully not from ESPN.
Next question? Yes, right there.
How was your live backup or contingency plan? I mean, was it like if the one database goes down, the second will take it over? And
So a question about backup again. What's our basically disaster recovery plan if Redis goes down? So Redis Labs has this cover for us now, but before we would replicate to another node, and then we would manually swap it. So it would take us a couple minutes and get to kind of think on our feet. Redis Labs has automated this to another AZ.
Can I ask the drone giveaway raffle bucket to keep it moving around to make sure everybody has their card in there, because we're going to give that away very shortly? Yes, right there.
So I had a question about there's a back-end worker persistence, right, with Redis, right, where you can add you're caching in memory, right? But are you using kind of like the background kind of persistence feature of Redis, or are you doing it yourself?
So we don't care if it persists for our application. However, Redis Labs will persist it. It doesn't really matter. And another challenge with Redis is actually when it persists. If you're on currently, if you're on the current virtual hypervisor virtualization on AWS versus the HVM virtualization, so AWS has new instance types now, and all other instance types are like previous generation instances. The virtualization technology is slightly different, and the newer virtualization technology is a lot faster. What I've heard from other people who use Redis is that if you're using HVM, you should use HVM because it's a lot faster, it's cheaper also. But when that saving, the snapshotting process that Redis kicks off happens, it's not as bad of a performance hit. Because right now on PVM, when that snapshot hits, it does hurt. So you have to always make sure that you use less than half the available RAM on your box, unless you want to turn off the persistence.
Next question?
That's actually not true.
Okay.
You can tell Linux to overcommit to memory, which is a kernel flag, and that'll get you out of that problem in really bad scenarios.
Maybe you're on HVM. I don't know though.
Possible.
Yeah, I've seen different things on PVM.
Yes.
What's the average payload that you're returning from Redis in terms of size?
Good question. I would guess under 100 kilobytes. What's the average payload being returned from API responses? I'm guessing under 100 kilobytes. Pretty small.
Next question? Right there?
question first.
Here. Hit it in advance.
How do you streamline development on infrastructure like this so that you're developing new features and also think about production and just those kinds of things?
So this is why for us, the question was how do you streamline development for things like this? So this is why for us, DevOps is such a big important movement, especially when you have so many services. You really need to empower the developers to provision the servers themselves and build the infrastructure themselves. It's quite hard to achieve, and so easy for an engineering team to want to build their own internal house. Everybody wants their own workflow, but realistically, it's very hard to do with even 50 engineers. I'm talking about 50 ops guys, not engineers. We have 3 ops guys, so we kind of refrain from building that. But this is where I think Elastic Beanstalk and Docker technology is extremely exciting for us. Elastic Beanstalk and Docker was going to empower the developers to kind of do that. And I think Amazon's got a good offering there. This is kind of the next stage of where we're going to try to go.
We only got a few more shirts left. Who wants to get the questions in? Yes.
If you have to rebuild your complete app and server all over again, what will be your dream stack? What will be your database? What will be your backend? What will be API programming protocols?
So if the question was if we have to rebuild our stack all over again and kind of do all over again, what's the dream kind of setup? Technologies always change over time, so it just really depends on the technology that's available. Or one of the things like API, I think we made some good choices there. Bleacher Report, obviously not. One of the things is the NoSQL movement is kind of gaining traction here. And relational databases, you're always going to have a single point of failure with that master. Even with RDS, the master failover I've seen take 5 to 10 minutes, or 3 to 5 minutes. So one of the things that will probably remove our architecture is that single point of failure. Some of the services still have that. When we fail over, I mean, it's still okay because we degrade to a static site. So we're still okay when we handle high availability that way. But it would be nice if you did it the way Netflix did it. They use Cassandra a lot. They use a NoSQL store, or they use Redis or whatever. As long as it's NoSQL store that's highly available, then you can avoid that single point of failure.
Could I just ask the Cam to make it to the other side of the room? Greg, maybe can help.
3 more shirts.
Yeah, 3 more shirts.
So during your presentation, the second API you guys developed, you said it was an API app. So is it one, say, Rails application that you've got all of your APIs in, or what does that look like, and how do you scale that out? If you've got one part of it that's more heavily contingent than another part of it.
So the question was, in the presentation I talked about an API app and how do you scale that further, when especially if that starts a bottleneck. So what we've done is kind of pretty much scale the API service for now. But what we've talked about many times is we've also, when I looked at the throughput report many years ago, we did the same exercise with API. We looked at the throughput API and we're like, well, a lot of these calls are stores, and some of these calls do other things. Like logically, they could be another API. So we have an API kind of running alongside API, and we shifted some of the traffic off of that too. But really, that hasn't really taken off yet.
Yes, up there.
Do you store like entire JSON and Redis, or is it more normalized?
You have to store the entire JSON because it's a key-based store. Or the question was, do we store the entire JSON into Redis, or is it more normalized? So we kind of do a little bit of both, but it's a key value store, so you have to store the whole thing ultimately. But with each item, there's a second layer of Redis caching there, and we kind of build that out.
Last question? Yes.
In your APIs, do you keep a global connection open when the API starts up, or do you do it at the handler level?
So the question was, in an API, do we keep a global connection open, or do we do it at the what level?
The handler level.
The handler level. No, I'm not sure what the handler level means, but I know that in the app, there's Redis is actually, it doesn't do connection pooling because it's event-based. There's no kind of advantage to connection pooling. There's a thread on this, the issues on the Redis open source project that covers this. But basically, we connect and kind of disconnect. Kind of, but so there's no kind of pooling within the instance that's running and connecting to Redis. But there's basically kind of a global variable that does maintain the connection. It just doesn't do it in a pooling fashion with multiple connections with one instance. So basically, every instance has 1 or 2 Redis connections on it, depending.
Okay, that was the time we have for our last question. Tung will be here for one-on-one questions, so don't leave. You can get your questions in just one-on-one afterwards. I want to give a great big round of applause to Tung Nguyen. We are now going to give away the drone. Let's see here. Let's make it away here.
Thanks, Tyler.
I ask you to kindly mix this all up.
That helps when you're bottlenecked.
Alright, now look the other way and reach in, grab one out.
I think you're
read it out loud.
I heard that from a buddy of mine.
Richard Bernard.
Yeah.
Richard Bernard, are you here?
Richard?
Once, twice, go back in the bucket. Try again.
Oh, man.
Sorry, Richard.
Bert Pico?
Bert Pico, congratulations.